So in this river swimmer problem, we have two cases. Okay, this is the first case in which river is flowing. If river is flowing, so V r vector. This is the velocity of river. Okay, now you are observer and you are on the ground. You are observer, you are on the ground, then you would say, sir, Vr is the velocity of river. Vr is the velocity of river. But you are observer, you are on the ground. So with respect to ground. Yes or no? Got it? You are observer, you are watching from ground. Then you would say, sir, Vr is the velocity of river with respect to ground. Or you will say, it is the velocity of river as observed by ground. As observed from ground. Got it? Got it? देखो, in still water, in still water, if swimmer swim, then Vs is the velocity of swimmer. Vs is the velocity of swimmer. Yes or no? Yes, sir. What is Vs? Sir, Vs is the velocity of swimmer. But in still water means if observer here, then what is the velocity of swimmer? Velocity of swimmer, this is with respect to river. Yes or no? I hope you understand this point. So in still water, what is Vs? Sir, Vs is the velocity of swimmer with respect to river or as observed from river. Got it? Yes. So in the first case, river is flowing. What is Vr? Vr is the velocity of river with respect to ground or as observed from the ground. Okay. In still water, Vs is the velocity of swimmer with respect to river, or we can say this is ability, swimmer's ability to swim. What is this? Is swimmer's ability to swim. I hope you got it. Now, what will happen when both the conditions occur together? River is flowing and swimmer is swimming. Okay, now next point. This is the first case, minimum time. This is river, width of the river is W, this point A, exactly opposite point B. Okay, now river is flowing. Yes sir, river is flowing with velocity Vr. Yes. Okay, in this case, swimmer wants to cross the river in a minimum time. Swimmer wants to cross the river in minimum time, or we can say as soon as possible or quickly. Okay. Now, in this case, this is the width of the river. Swimmer wants to cross the river from here to here as soon as possible. So, he'll put all the efforts in this direction. Swimmer wants to cross the river. मैं लिख देता हूँ. Swimmer wants to cross the river as soon as possible. It means swimmer wants to cover this width as soon as possible. This width as soon as possible. So let's say this is x-axis, this is y-axis. So I'll put all the efforts in plus y direction. It's so easy. Swimmer wants to cover as soon as possible. He'll put all the efforts in plus y direction. Yes, sir. Okay. But because of river flow, river is also flowing. VR vector. Because of river flow, net velocity of swimmer is V net vector. Yes or no? Yes, sir. Swimmer puts all the efforts in this direction, but because of river flow, this is the net velocity of swimmer. So swimmer goes from here to here, right? So swimmer goes from A to C. Swimmer wants to cross the river as soon as possible, so he'll put all the efforts in this direction, this y direction. But due to river flow, net velocity becomes V net and swimmer goes from A to C. Now, as we know that speed is equal to distance upon time, so time is distance upon speed. Yes? Yes, sir. So, swimmer wants to cover this W distance. Swimmer wants to cover this W distance with speed Vs. Yes? Swimmer wants to cover this W distance. This is the distance and this is the speed. So what is the time? So time to cross the river. Time to cross the river. So time will be distance upon speed. I hope you got it. Time is distance upon speed. This is the distance. Speed is Vs. In y-axis we are assuming, right? So time to cross the river, this is the minimum time with which he will cross the river. Okay? Now, this is the net velocity. So you can see here, this is VR vector, this is Vs vector. So we have two vectors, VR vector and Vs vector, perpendicular to each other. Then the resultant becomes like this. This is net velocity vector. Okay. What is the magnitude of net velocity? Sir, this is the magnitude of net velocity. Under root of VR square plus Vs square. Okay. This is the net velocity.